Imagine you just bought a podcast episode, you scanned the code, tapped send, and 3 seconds later, the seller saw your payment. Sounds like Apple Pay, except there was no bank, no Visa, no PayPal, no company of any kind between you and the merchant. A credit card payment passes through 5 intermediaries. Bitcoin skips all of them. Same speed, 0 middleman. Bitcoin runs on 3 components. Understand those, and the whole system clicks. Every digital payment rests on a hidden assumption: trust in a central record keeper. When you send money through a bank, you trust that institution to debit one account and credit another honestly. Billions of people accept that arrangement because they have no alternative. Bitcoin's core claim is that software can replace that trust entirely. Every user runs the same open source code and independently verifies that every rule was followed. No permission required, no special access. The system is called Trustless, and that doesn't mean trust disappears. It means trust is distributed across mass and code instead of concentrated in one company's database. 3 interlocking components make this possible. Component 1, wallets. A Bitcoin wallet is a pair of cryptographic keys. The private key is your secret. It proves you own the funds. The public key is your address. It lets anyone send you Bitcoin and verify your signatures. Think of the private key as the combination to a safe. The public key is the safe's serial number printed on the door. Anyone can see the serial number and send packages to the safe. Only the person with the combination can open it and spend what's inside. Lose the private key and you lose access to your funds permanently. Component 2, transactions. When Alice wants to pay Bob, her wallet constructs a digitally signed message saying, in essence, move X Bitcoin from my address to Bob's address. This message broadcasts to a network of thousands of computers called nodes. Each node independently checks 2 things: whether Alice's address holds enough Bitcoin and whether the digital signature is valid. If both checks pass, the transaction enters a waiting pool, accepted by the network, but not yet permanently recorded. That final step belongs to our third component. Component 3, miners. Miners compete to bundle waiting transactions into a new block by solving a computationally intensive puzzle. The winner appends their block to the blockchain, the single shared tamper-evident ledger of every transaction ever made. Think of each block as a page in a ledger chained to the previous page, so no entry can be altered without breaking every link after it. This replaces the bank's private database. See how the 3 pieces interlock. Wallets create transactions, the network validates them, miners permanently record them. Those are the pieces. Now watch them work together. Bob runs an online store selling premium podcast episodes. Alice chooses pay with Bitcoin at checkout. Bob's system generates a QR code. And this isn't just a bare address, like it encodes a payment URI, a standardized text string, bundling 4 fields: destination address, exact amount in Bitcoin, a label reading Bob's store, and a description reading premium podcast episode 12. Alice opens her smartphone wallet and scans the code. Every field autofills. She reviews the details and taps send. Her wallet signs the transaction with her private key and broadcasts it to the network. Thousands of nodes validated within moments. Alice has enough funds. The signature checks out. The transaction enters the waiting pool. Bob's point-of-sale system detects the incoming transaction in about 3 seconds, roughly the same time as a credit card authorization. He grants Alice access to the episode. The deeper confirmation, when a miner includes the transaction in a block, takes around 10 minutes. For a small purchase like this, the initial detection is sufficient. Once a transaction is on the network, anyone can verify it. A blockchain explorer is a search engine for money. Enter an address, a transaction hash, a unique fingerprint for that specific transaction, or a block number, and see exactly where funds moved. This is trustless verification made tangible. One caveat: the Explorer operator can see your searches and may link them to your IP address. Verifying your own transactions has a privacy cost. A common concern is that one Bitcoin costs tens of thousands of dollars, but you don't need to buy a whole coin, just like you don't buy a whole gold bar to pay for coffee. Bitcoin is divisible to 8 decimal places. Let's look at the different units. At the top, we have one Bitcoin written as BTC with a value of 1.00000000. Think of this as a major purchase. Next is 1 milli Bitcoin, written as MBTC, which equals 0.00100000. That's 1/1000th of a Bitcoin, enough to buy a cup of coffee. Then we have 1 micro Bitcoin, written as UBTC, equal to 0.00000100, 1 millionth of a Bitcoin, roughly enough to tip for a web article. Finally, at the bottom is 1 Satoshi, written as SAT. Its value is 0.00000001. That's 1/100 millionth of a Bitcoin. The Satoshi is named after Bitcoin's pseudonymous creator, and it is the smallest possible unit. Notice the scale. From 1 Bitcoin at the top to 1 Satoshi at the bottom spans a factor of 10 to the 8th, 100 million. That's the precision built into Bitcoin's design. Step back. Alice's wallet created a signed transaction. The peer-to-peer network validated it. A miner will permanently record it in the blockchain. Each step is governed by open rules that any participant can verify independently. No institution had to approve, process, or settle the payment. That is what trustless means. Not the absence of trust, but trust distributed across mass and code instead of concentrated in one company. This architecture, wallets, transactions, consensus, is the template for an entire category of systems that operate without central authorities. To see this for yourself, open a blockchain explorer and search for any transaction. The entire system is right there. Open, verifiable, no permission needed.